morning, good afternoon, good evening, whatever the case may be. We are back and we are better than ever. And today we're going to talk about where functions meet. Like maybe they meet out at the store, or they go to the movies, something like that. Maybe they're doing some Pokemon Go. But in this case, where functions meet are where they intersect, as shown in these drawings. And for our purposes today, we're really talking about quadratics and lines. Could be two quadratics, we'll see. And as we have discussed, excuse me, there are a couple of ways that a line, a few ways, actually three, that a line and a parabola can meet. They can intersect in two places. They can touch, and so they touch in one place, or they do not touch at all. Of course, if you call this function, let's just say this one is f of x, and this one is g of x, and you're said, all right, solve for the values of x, where f of x is equal to g of x. All you would have to do is set them equal to each other, and what you would find is they are equal at these points of intersection. And depending on the case, we would only be interested in their x values. Those would be considered the solutions. So let me show you what I'm talking about. Find the coordinates of the points of intersection of the graphs with equations y equals x squared minus x minus 18, which is going to be a parabola, and y equals x minus 3 without technology. Well, all we have to do is graph this, or I'm sorry, set them equal to each other. Where they intersect is where they are equal. So I set the two equations equal to each other. I am going to solve, subtracting x and adding 3, so that's minus 15 equals 0. This is easily factorable. X minus 5 times x plus 3 equals 0. ZPP. I thought I heard you say, yeah, you know me. So x equals 5 or x equals 3. And while it didn't say to use technology, I'm just going to show you real quick. Let's see, that's a calculator. So to add a graph, I am going to do that. And then I'm going to type in the two functions. I have a bad short-term memory. So the first function is x squared minus x minus 18. Bam. Okay, so we don't get the full picture, but I don't think we're going to need it. I can hit tab to put in the next function, x minus 3. Boom, chugga, lugga, lugga, and there we go. And then we can find out where they intersect by going menu, analyze graph, intersection, and then I drag my mouse and go to the left of the first point of intersection. And then I'm going to drag this, and the x value is negative 3, which we got. Do it again, analyze graph, intersection, left, drag, right, move that up so we can see it. And let's see, I will go ahead and take a picture of this so it's on our notes, or it's on the video, I suppose. Bam. And there we go. Okay, so we got the same solutions, right? X equals 5 right there. X equals negative 3. Nice going, Mr. B. So that should be negative 3. I hope you caught that before and were yelling at your video screen. So right there, okay? Same dealio. Now the next one, we're going to completely use technology. Consider the curves y equals x squared plus 5x plus 6 and 2x squared plus 2x minus 4. Solve for x, so we set them equal to each other. We could solve for it by hand. I can't remember if it comes out nice or not, but even if it didn't, we could get the exact answer using the quadratic formula. Let's go ahead and graph them. I'm just going to add a totally new page so I don't have to clean that up. Add graphs. You should always be in a document. Don't be in Scratchpad. All right, so x squared plus 5x plus 6, boom. There we go. So that's the third function I've input. Let me get that out of the way. I hit tab to enter the next function, which is the fourth function as indicated right there. So that's 2x squared plus 2x minus 4. Boom. And there we go. Now it looks like they might intersect in two places up here. So what I can do is double click, and I'm going to make that maybe 25, the scale, and it goes upwards. That is open wider, so maybe I need to go a little bit higher. Let's go 75, and there you go. Okay, so you saw how to do that. You can also click and drag your screen a little bit to see things. Okay, so I'm going to get that out of the way. Now I'm going to find my points of intersection to find the solutions. Analyze graph, analyze graph, intersection, go to the left of the first intersection, click and drag, and I get the point -2, 0. I'm going to do the same thing here. Menu, analyze graph, intersection, to the left, click, click, drag, sorry about that, and 5 and 56. Okay, so I have my solution here. Let me take a picture of it, and I'll copy and paste it. Boom, boom, boom. All right, so now we have that to use. Okay, I'll put it over there for us. Okay, and so now for part A, I get x equal to -2, which is right here, and I get x equal to 5, right here. So those were factorable. We could have done it easily by hand. So we've done part A. B, solve for x squared plus 5x plus 6 greater than 2x squared plus 2x minus 4. So they're asking, when is this function greater than this function? Okay, well, x squared plus 5x plus 6 is the black line right here, and it's greater than it wherever it is above it. And you can see, actually I wanted to do this in blue, you can see that in this part right here, it is above 2x squared plus 2x minus 4, which is in pink. So it's only greater than this function on this interval, which is between -2 and 5. So we're going to write just a little inequality or equality expression, sorry. And we got to be careful because it says solve for x greater than, not greater than or equal to, greater than. So that's from -2 to 5. And -2 and 5 are not included because those are the points at which they are equal. So in between those is where this function is greater than this function. Okay, last thing we're going to do is this example. Y equals 2k plus 6 is tangent to 2x squared minus 3x plus 5. And tangent means it touches in one and only one point, near the point of tangency. Okay, so we got to see where they're equal. So where does 2x squared minus 3x plus 4, where is that equal to 2x plus k? That's a k, 2x plus k. And I'm going to move everything to the left side, so I get 2x squared minus 3x, -3x minus 2x is minus 5x, plus 4 minus k is equal to 0. So k is a constant, so that means this is my constant term. And if they only touch in one point, that means there's one solution or a double root to this quadratic, meaning the discriminant must be equal to 0. So I'm going to calculate the discriminant. So discriminant is equal to b squared minus 4ac. Need that to be equal to 0. So that is, my b is -5. -5 squared is 25. Minus 4 times 2. And c is times 4 minus k. Need that to be equal to 0. 25. Let's see. Negative 4 times 2 is negative 8. So I'm going to distribute negative 8 through there. And negative 8 times 4 is negative 32. And negative 8 times negative k is plus 8k equal to 0. So 25 minus 32 is negative 7 plus 8k equal to 0. Let me move over here. 8k equals 7. So k is equal to 7 over 8. So that means when k is 7 over 8, then y equals 2x plus k is tangent to y equals 2x squared minus 3x plus 4. So I'm going to write 2x plus 7/8 here. And I'm just going to quickly graph it to show you all. Okay, so I'll add another page, control plus page, add another graph, everything's nice. So this was, remember, 2x plus 7/8. Bam. And it's tangent to only with this equal to 7/8, it's tangent to 2x squared minus 3x plus 4. Let's have a look. And there, that's a nice little picture. Little thick. I'll move this out of the way. I think I will. Okay, move it over here. And it's tangent right there. Maybe we'll take a little zoom, menu, window. I love the zoom box. Just get a little closer in there. It'll zoom in for us. And it's tangent right there at that point when k equals 7/8. Now, if you don't have your calculator yet, it's coming in. I want to show you how you can get a free trial version. Just Google TI Inspire CX 30-day trial. And it should be the first one up right here. And then you can download, and it'll give you a 30-day trial. Of course, download the correct one. And then you can use that until your calculator comes in. All right, so I hope you enjoyed all of that. I know that I did. And let's see how Angels and Airwaves are doing on our way out of this popsicle stand. And we shall see you later. See you next time. I am... Oh!